Hi everyone. I'm going to spend a bit of time going over the practice questions from class today, apparently while looking into this incredibly bright light. First thing I will need to do though is find a more comfortable place in the frame. I'm thinking maybe down this way. Ah yes, that is much better. Okay. Alright, first question that we've got on here is describing the front view, the left view, and I remember in class, the left view was actually a typo, so I'm going to scribble that out and change that to right. Okie dokie, so we're gonna first of all look at the right view of the the front view, so I'll highlight that yellow, of the shape that's on the left. So remember, that means I'm gonna have to draw all the faces that are facing the left-hand side. So we've got this one towards the bottom there, we've got this one just there, and the one just above it here as well. No, notice, I've dribbled a bit on the page, not dribbled, but with the highlighter. Now you'll have to remember, of course, what these shapes look like from the left-hand side, and then draw that on the grid paper underneath. So notice that it's gonna come straight down like that. You're gonna have two blocks to begin with, and then one block going off to the side in a sort of L shape. This is kind of hard to show without actually pointing to it, but I'm sure you can get the idea by following the screen. Cool, so that's what you would see if you were looking from the left, and we can label that the front view, or just front will do. Alright, now we want to have a look at the right hand side, and these are all the faces that are facing the right hand side. So we've got this one just here, that's facing towards the right, so is this one here, and so is that one there as well. Now this is still forming like a sort of L shape, but this one's more of like a backwards sort of L. So it's almost like in fact it is a mirror image of the previous one. It looks a little bit something like this. We can label that the right view and colour it in nice and blue like that. Alright, last one is the ones on top, the ones that are facing up into the air. And these are going to be these four squares. It's hard to draw squares with the, the 90 degree corners of the highlighter, but it's all the ones facing upwards like that. Now notice that looking down from the top, you can see four of those facing upwards. So if you were to look at that shape from the top facing down, it's going to just look like a grid of four like this. I'm going to change this one. That wasn't my best work. And you can label that top because it's the view from the top. Now you don't need to make them, these different colours on the test, but it can be helpful, I suppose, in actually trying to work it out. You don't need to if you don't want to, but if it helps you, go for it. Now I'm going to do this next one real quick. Four are facing the left-hand side, which is our front view. So we've got four like that. 1, 2, 3, 4. Like this. Label that front as well. We've got a little L shape on the right hand side just there. So if you look at that shape from the right, you'll get like an L sort of shape that looks like this. Going to colour that in as well, just for consistency more than anything. Right view, and then again, this is something that a few of you asked about today. You can definitely see that there's two facing upwards just here on the closest side to us. And you can also see that there's one here as well. I might just lift up and point to it. You can also see that there's one just here, and you're not sure if there's one behind it. So look, because you don't know for sure, you could leave it out, but it looks to me that that's going to be an L shape, like a big L shape kind of thing. So look, if it was me in a test situation, I'd probably just draw 4 in. But if you drew that as another like L shape, like with 3 blocks instead of 4, I wouldn't necessarily mark you down for that, because you can't say for sure that there is another block there. But that's what I'm going to do on mine. Cool, question 1 is done, and we can say hooray. Hooray. Okay, I've done something kind of annoying here, and I've got the isometric paper on the next side of the page. So, which isn't so bad when you're doing it in class, but when you're doing it on the screen, I'm going to have to do a bit of this. Anyway, so remember that front means what I'm going to do is draw this first shape here, shape number 1. Now, first I'm going to look at the front view, which is the view that's facing the left-hand side, and I can see that there's 2 units going horizontally while on the bottom, and then it's 4 units tall as well. So that's what I'm going to draw on the next page. So I've got 2 units along the bottom, like this. So remember those 2 units, followed me a bit there, these 2 just here. You can think of those as being flat, like they would be horizontal in the real world, and that's the way you would draw them on this isometric paper. Because remember, if I look for this handy Nike box prop, the bottom of this shape is flat with the ground, but if you look at it from an isometric view, see how it's coming like down at an angle, like this. So you draw it in that way on the isometric paper. Now I'm going to make it 4 units tall, so I'm going to add 1, 2, 3, hang on, 1, 2, 3, 4. Like that. Ooh. Cool, so that's that backwards L sort of shape like we had up here. Alright, now I'm going to look at the right panel, so all the panels that are facing right. I've got 1, 2, 3, 4 units, just in like a single file sort of thing, all facing right. So looking from the right view, I've got 1 block wide, and I'm going 4 blocks into the air, like this. Cool. And then looking at the top view, normally with the top view, you sometimes don't have to add in too much, but looking on the diagram here, we've got 2 blocks on the top just there. So what I'm going to do is just scroll down and see if I fill in the rest of this gap just here and this gap just there, excuse me, if I was looking at that from the top, would I see 2 blocks? And the answer to that is yes. I think I'll colour these at the end, but just sort of like skip to it real quick so you can see like the comparison. What I'm going to do now is draw the shape number 2, not hashtag 2, number 2. So facing left, I've got 5 rows on the bottom. It's 2 rows high, except there's 1 row missing at the end just here. So I'm going to go 5 across along the bottom. 1, 2, 3, 4, 5. I'm going to go 2 cells up and then go across 4. 1, 2, 3, 4. Then down 1 and across 1 again to get that little chunk. Oh, that line wasn't very good. Up again. Cool, that's our left view. Looking at the right view, it's a block of 4 like that, so I'm going to make sure I've got that square shape on the right. And then looking from the top view, I've got, well here I've got a block of 10, it's 2 rows of 5. So what I'm going to do now is start to fill in the top here and just see how many shapes I've got. So if I come across up to here where this little edge meets up, that'll give me 2 rows of 4, not 2 rows of 5. So it sort of seems like you're too short. But the other 2 shapes come from the very end, just this line I'm drawing in there. So that's that little extra wedge part that's that's missing. Now what I'm going to do is colour these in magically and then show you the finished product. Alright, cool. So now that work of art is complete. So notice that I've coloured these 2 shapes the same way I've coloured the ones on the top. So the left view is yellow, the right view is blue, and the top view is purple. So have a look at these colours that I've labelled on here for each side, and then just compare them with the ones on the bottom just here. So these tee up with the faces from the plan that you need to use. So if you're having a bit of trouble seeing where something came from, that might be something you might wish to look at. Alright, now we're up to what I think will probably be some easier ones. Alright, reflect this shape in the line shown. I'm going to change my thickness for this one. Let's change the colour too. Okay, so reflect this shape in the line shown. The line shown, or the line that you reflect in, is pretty much always going to be the dotted line. So sometimes you'll have like your axes on there and that kind of thing, but it's always the dotted line. No, remember it's going to look kind of the same, but as if it's been flipped over. Like if I turned my computer over, it'd be the same shape, but flipped over the other way around. But if you're not quite comfortable trying to visualize it that way, the way I would do it instead is pick a point. So maybe the top corner just here. See how many units it is to the middle, which is 2. That means that I need to draw another 2 units on the other side of the line. So up to here, like that. Excuse me. I can do this for another point. I'll go from here, 2 units to there, 2 units to the end. I'll pick this one, maybe. I need to go 3 units across, 3 units across like that. So that gives you an idea of the way that your shape's going to go, and then you can usually fill it out from just from looking at it. But in case you don't want to do that, pick another point here. It's 1, 2, 3, 4, 5. So we go 1, 2, 3, 4, 5 to here. Same with this one, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 to there. And finally this one here, go 1, 2, 3 across and 1, 2, 3 to here. And that's just a case of joining up the dots. That one goes to there, that to there, that up here, that up here. You should use a ruler for this, by the way, but it's hard for me to do on my computer. The glass is so slidey. Okay, so now, and if you want to, you can get rid of the lines that you use, like the dots you use to count them up, but that doesn't really hugely matter because it's a way of showing working out. In fact, probably just leave them in so I can see what you've done. So as you can see, it looks like it's just been flipped over. It's the same, but reversed in that axis. Same story for this one here. Switch to red. And change the thickness again. Cool. So this one, it's not in the, I'm going to draw a quick line down the y-axis. We're not flicking it around in that line. I mean, reflecting it in that line. We're going around the dotted line, this one here. So what you will need to do is see how many units you've got from D. So this is the first point I'm choosing here, D. Units from D to the line is 1, so we need another one on the other side. And if you want to, if the question asks for it, you can call that D apostrophe because it's the new version of D. Same with E, that's new version of E just here. Distance from A to the line is 1, 2, 3, 4, 5 units, so then we go 1, 2, 3, 4, 5 units here. That's new A. B, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, new B. And then C is 1, 2, 3 units, and then 1, 2, 3 units again, so that's new C. And if we join all of these up using a ruler, you should find it's the same flipped over. Cool. For complicated shapes like that, it does help to put the actual lines of working in. I find that to be quite helpful until you get a bit more confident with it. Okay, rotate the shape as directed. Rotate the shape 90 degrees clockwise. I guess if you're going to rotate it as directed, you would be rotate it. You wouldn't rotated it. Anyway, what that means is, and this is hard to show you on the. Actually, I've got an idea. We're going to rotate this 90 degrees. 90 degrees is a quarter term. So kind of like going from 12 midday or midnight or whatever to or from the hour till say quarter past, from the 12 to the 3. That's a 90 degree turn. And on the piece of paper, a quarter turn looks like, hopefully this doesn't completely break it, it's going to look like that. So notice in the point that says P on there, I'll draw that in real quick. Or do I want to do that? Yeah, I do actually. That point there, P, that's the point that it's rotated around. That's where the shape is stuck to. So if you were to put your finger on the paper like that and then rotate the shape 90 degrees clockwise, that is, oh dear, I have broken it now. Please bear with me while I find it again. Yeah, you would end up with a shape that gets onto the, it's still going to be in line with the axes, but now it's sticking into the next quadrant. And if you're thinking, well, that's all well and good, but I can't pitch that very easily, this is the way I would recommend that you do it. So draw in a line like a crank handle kind of thing. And you can do this between the the point of rotation, which is this just here, and then draw it in between a point on the shape. I'm going to call this A, like that. So now instead of rotating a shape 90 degrees, we're just going to rotate that little line 90 degrees. If you spin that around like I was showing you before, so you stick it down on the point P and spin it around, it's going to end up being the same length, so 6 units, but it's going to be facing vertically. So this point here that I'm circling, that's new A, that's A apostrophe. Cool. Now you can picture which way the shape is going to be rotated, and you know that this long line is now like facing the is on the y-axis. So now you can draw in this other line here, which is what would I call that? 4 units across. And on the subject of drawing in like a crank kind of thing, it's often just easier to make it like an L shape or something like that. So I'm going to draw in a new crank like this. It's going to go 6 units across to point A, and then 4 units across to point B. So now you've got a shape that I'll draw separately on the side that looks like this. And if I draw a point here and imagine that I've rotated that 90 degrees around, you can imagine pretty easily what the new shape is going to look like. So then it's just a case of joining new B with the origin like that. Cool. Rotation is actually pretty straightforward. They're just, as long as you draw in those cranks, they're pretty easy, I reckon. Okay, describe these translations from yellow to green. I think I'll blaze through these pretty quickly, as I've noticed that the video is getting a little bit long. All right, remember translations. Translations generally means slide only, like if you've just slid it and moved it around, but they've done combined transformations in here as well. By which I mean this first shape here, so going from yellow to green, we've gone 3 units across and then 3 units up. I've picked the same point on the same shape for consistency. So I would describe that as 4 units to the right, and then, oh, no Josh, 3 units to the right and 3 units up, the whole along the corridor and up the stairs thing. I'm going to make that a little bit less thick actually. Now, for the second one here, it seems to me like the shape has been reflected. So that's how you describe it. The shape has been reflected, but you can actually draw in the line that it's been reflected about. It's hard to see. Maybe I will make it a bit thicker again. If you can use a different color or whatever on your test, that's totally fine. Whatever gets your point across is okay with me. So your answer for this one could be, it's going from yellow to green, so you could say yellow shape reflected in this line. So that's not a translation actually, it's actually a reflection. This was probably the trickiest one in terms of combined ones. Here we've gone 2 units to the left and then 2 units down. But then, actually I'm going to draw that in. If I just move that 2 units to the left and 2 units down, we would then have a new shape just here, like that. But that's obviously not the final spot because it's been rotated to the left. So what I would do for that one, I would label this point that the bottom has arrived at as P. So I'd say 2L, so it's been moved 2 to the left and 2 down. And then I would say then rotated 90 degrees anti-clockwise, because it's the opposite to clockwise. About point P. And that's a completely acceptable answer. Then the last one, nice and easy. I'll pick 2 of the same points like that. That's gone 3 units to the left and 3 units down. That's actually not as easy as it looks. The reason being that to track that the movement of that point, I've sort of drawn through the second shape here. But just remember, you've got to see the distance between the same point on two different shapes. That's the key. All right, we're on the home stretch now, and I'm just going to make sure my phone is still recording. Otherwise, this will be a big, not a waste of time. I just have to do it again. Now, this is all about angle relationships. Find the size of the following angles. I'm going to go through these fairly quickly. Angle B is equal to 60 degrees. Angle A is equal to 120 degrees. The reason for both of those is that those angles are vertically opposite. If you've got two straight lines like this, and they meet at a certain point, the opposite angles about that point are going to be the same, and the relationship is described as vertically opposite. Next one here, B is going to be equal to 75 degrees. The reason for that is that it's a straight line. We know that the angles on the straight line add up to 180 degrees. So if this one is 105, angle B is going to be what you have to add to 105 to make 180 degrees, which is 75 degrees. Similar story for this one here. C, we know because of that little square thing that this angle is a right angle, so which is always 90 degrees. For right angles, we just write in that little square thing instead of writing 90 degrees. So we know that angle B is going to be whatever you need to add to 35 to give you 90, which is 55 degrees. Cool. This one here, angles around a point, so around this whole point just here, they've got to add up to 360 because it's a whole circle. So angle A is going to be, well, it'll be 360, take away 120, which is 240, take away 85, 240, take away 80 is 160, take 5 is 155 degrees. All right, last two. All right, these are the ones that we've done quite recently. We've got two parallel lines. We've got an intersecting like traversal going through both lines. And we've got angle here, which is 110 degrees, and another angle just there. That angle is the same, it's 110 degrees, because they are corresponding angles. Or the relationship is corresponding. Sometimes you'll be asked to state what the relationship is as well. Same with this one here. Angle X is the same as 100 as the other one. It's 100 degrees because we've got two parallel lines and we've selected alternate angles on there, and alternate angles are always the same. If I can give you guys just one tip for this one, notice that in these relationships, there's only ever two angles. So if I pick the one on the right as an example, you've got 100 degrees as the angle just here that I've circled. This angle here is the co-interior one. And remember, co-interior angles always add up to 180. So this angle here is 80 degrees. Because of vertically opposite angles, we know this one is 100, this one is 80, this one's 100 as well, and both of these are 80 also. Now notice that we've got an obtuse angle and an acute angle. We've got a small one and a big one, so 80 degrees and 100 degrees. So it's a pretty safe bet which angle it is that you're being asked to do, or asked to work out. You're given the big angle here, and the question is saying find the value of this big angle here. If it looks the same, it's going to be like 9 times out of 10, if you're not sure, it's going to be the same as the other big angle. And if it looks like it's the smaller version of the angle, so this one here, the co-interior one, then they both have to add up to 180. So that's a quick sneaky way that you might wish to consider doing it. All right, last one. I'm going to check my video again because we're on the home straight. Oh, half an hour. Thanks for sticking around if you're still here. It's weird talking to yourself for this long. All right, and these angles, A and B are, in the diagrams, angles A and B are, oh, okay, cool. So A and B in this one, I'm going to draw a little shape around each of the angles. Notice it makes that F shape, which we associate with corresponding angles. It's like it's the same one on each side. Like if we were to completely block out everything on this side, that angle that you see there, B, looks exactly the same as angle A on its own. They're identical. They're all, which means they're equal in size. Next one, we've encoded this one before with two angles meeting on either side of a point. They're vertically opposite and they are always equal. Very good. These ones, I'm going to draw, again, a shape around the angle like this. So that's around one angle, that's around the second angle. It's made that C sort of shape, and they're both on the inside, which we associate with being co-interior angles. Now, co-interior angles add up to 180 degrees, and the word for that in maths is supplementary. Supplementary just means adds up to 180 degrees. All right, last one. Oh, there's more after this. Okay, again, I'm going to draw the shape around each one. So there's the angle there, there's the angle there. We've got that Z shape that we associate with alternate angles, and they are equal as well, which I can't see equal on there, so I'm just going to leave that. And for these angles, state the relationship and the value of the pronumeral. So again, draw in that angle, draw in this angle here. Z shape, which remember is their alternate angles. So that one is 60 degrees. Next one here, we're looking for angle Y. 45 degrees is a distractor, don't worry about it. These are vertically opposite angles. So Y equals 135 degrees. And they're vertically, gotta watch my spelling, opposite, and my handwriting as well. All right, next. The next one is a tricky one because they don't really have a direct relationship. They're not inside the or between the parallel lines, so we can't describe them as like alternate or anything like that. The way I would look at this one instead is to, look at the what do you call them, vertically opposite angles first. So I'm going to fill in 130 degrees here. I'm going to fill T in here as well. So remember, T is going to be the same as what's on the other side just here. So you can just write another T next. We don't know what T is. We're trying to work it out. But we do know that T at 130 is going to add up to 180, which means that T has to equal 50 degrees. Cool. All right, I think that'll just about do it. So yeah, there's not really a lot on here that's not going to be in the test. Oh, sorry, there's not much that's in the test that's not in here. So if there's something you're still struggling with, it will make sense for us to spend a bit more time going over it. Yeah, thank you for watching and goodbye.